Okay, today we're going to be talking about the division properties of exponents. So far we've already talked about the multiplication properties of exponents. Now we're going to talk about the division ones. Okay, so if you're still struggling with the multiplication ones, go back and watch that video. So for the division ones, we're now going to look at problems like, I don't know, let's say you had 3 to the 6th divided by 3 to the 3rd. Well, what exactly does this mean? Well, 3 to the 6th, we know that's 3 times 3 times 3. 3 times itself 6 times. Divided by 3 to the 3rd is 3 times itself 3 times. Now, if we look, these 3's kind of factor out to 1. So that one factors out to 1 there. This one factors out to 1 here. This one factors out to 1 there. And we're left with 3 of these guys, or 3 to the 3rd power. Okay? So something to note about when you divide the same base, so our base here was 3, when you're dividing the same base, we subtract our exponents. So again, when you're dividing the same base, we subtract our exponents. And as you move on, you should be thinking about this picture in your head. So we had 6 of these 3's up here, 3 on the bottom. There you go. And notice that you're multiplying too, you're not adding. Okay, so let's try a problem now. They get a little bit more complex. So let's say you have x squared y to the 4th divided by x y squared. Okay? And you're right, we like numbers too. So let's throw some numbers in there. Let's do 2 and, I don't know, 8. Okay, so first step, let's just combine each term. So I have an x squared here and an x down here. What I like to do, this x, when you don't see the power that it's being raised to, I just put a 1 there so I know it's x to the 1st. Now I have the same base being divided, so I can subtract the exponents. 2 minus 1 gives me x to the 1st. And now I can do the same exact thing with y. So I have y to the 4th divided by y squared. So now I have y, we're multiplying these. Same base being divided, we subtract the exponents. 4 minus 2 gives me 2. And then finally I can look back at my numbers. Well, 2 divided by 8 is 1 over 4. So all this is over 4. So here is what it simplifies down to. Okay. Okay, let's try one more example. Well, we'll try a few. They'll get a little bit more difficult though. And now let's try to incorporate some of the stuff we've learned from the multiplication properties of exponents. Okay? Great. So let's have x to the 3rd. Okay? So we have this guy. Now, let's take it one step at a time, and we want our answer to have no negative exponents. Okay, so one step at a time. Answer's going to come down here. Okay, let's worry about x first. I have an x here and an x here. When you have these two, I guess we said we'd add some of the other properties too, so I don't know. We'll add a y to the 8th, just to be happy. Okay. So when you have the same base being divided, we subtract the exponents. Well, now we have x to the 3 minus a negative 1. Be careful there with the sign. 3 minus a negative 1 gives me x to the 4th. Okay. And of course you might be asking yourself, but Mr. Pons, how do I know if it goes in the numerator or denominator? That's a good question. One kind of rule of thumb is you go where the bigger number's at. 3 is larger than negative 1, so there are going to be more x's up here, so x to the 4th. And it kind of makes sense here. You have y squared over y to the second. So we could think there are more y's up here than there are down here. But, good catch, we have y to the 8th here. So let's combine these two first. Y to the 4th times y to the 8th, as we learned from last chapter. Same base being multiplied. Add the exponents. So now we have y to the 12th divided by y to the 2nd. And there, same base being divided, so you can subtract the exponents. So we have y to the 10th. And this, we know it's on the numerator because we had 12 y's up here and only 2 down there. So there are going to be more y's in the numerator. And then finally, we have z to the negative 2 over z to the 8th. So this becomes z to the negative 2 minus 8. Or z to the negative 10. And if you do it this way, your number is always going to be on top, and then we can fix it at the end. Or in the numerator, excuse me. And all this is over 1. Okay, and we don't want our answer to have any negative exponents. That's good, that's good. Oh, z to the negative 10th. So now we learned in the last chapter, to make that become positive, we can just bring it downstairs. So now we have x to the 4th, y to the 10th, all over z. And that's right, that's right. So again, I think one of the most common misconceptions, like, well, how do I know to put the number in the numerator or denominator? Well, if you subtract from the numerator first, and you're taking away the denominator, you're always going to have it in the numerator. Or you should think in your head, you have more here, you're subtracting away those. Yeah. And then at the end is when you can adjust to put them in the denominator if needed. Okay. Okay. Keeping this in mind, before we do one more example, I do want to talk about, let's say you now had this question raised to you. Well, what is x to the 0 power? We don't know. Okay, because we're going to start seeing these. Well, let's think to ourselves, I know that 5 minus 5 equals 0. That's true. So I could take this and substitute it in for that. So now I have x to the 5 minus 5. Because remember, that equals 0, so I can just put 5 minus 5. Now we know, we should be thinking in our heads, when we're subtracting exponents, what happened to my bases? You divided them. Yes! So this became x to the 5th over x to the 5th. That was hard for you to get there. Think about working this way to get here. You're dividing the same base, so you subtract the exponents. Well, these are the same thing, so that just equals 1. So anything raised to the 0 power equals 1. There is a little bit of a, I will say, a disclaimer-ish type thing. 0 raised to the 0 power, this doesn't necessarily equal 1. Some people say it's 1. Others say it's undefined. It's not 0, but we're not going to throw any curveballs at you like that. So anything raised to the 0 power is 1. Now, let's take everything we have learned so far, bring it together, and solve problems. Okay, let's see how it goes. X to the 3rd times y to the negative 3 times z to the 8th. Okay, and let's say we have times 2 squared y to the negative 2 x to the 0 z all over, let's do y, negative 1 z, let's do 2 cubed, x to the negative 3, all that raised to the 0 power, x to the negative 1. And let's take all that. Okay, so this one's a little complex, but we've got this. Okay, first thing I want to do, let's simplify everything and combine like terms. Makes our life a little bit easier. So let's worry about the numerator first. Well, first thing, let's look at all my terms here. Realize something that a lot of people kind of miss. We're multiplying everything. That's why we're able to do all this stuff. It's because we're multiplying everything. Okay. Well, I see x to the 0 here. That's nice, because anything raised to the 0 power is 1. So this guy is pretty much gone, because anything times 1 is whatever it was. So I only have one more x. Okay, so now I have x to the third. Now let's combine all our y's. Well, I have y to the negative 3 and y to the negative 2. When you're multiplying the same base, we add the exponents. So y to the negative 5. Kind of cross them off if you want to as you go. Now I have z to the 8th times z. Remember, when you don't see an exponent, it's a 1. Multiplying the same base, add the exponents. Z to the 9th. Okay. And then I'm left with just 2. 2 to the second power. Okay. All that's over. Well, look at all this. We could distribute this to each term. Okay. But we notice this whole thing's being raised to the 0 power. So this whole thing here is just equal to 1. Don't have to worry about all that. Great! Now I can take this guy and distribute it to each term. And when you're doing that, when you're raising a power to another power, remember we multiply the terms in the last video. So negative 1 times negative 2 is 2. So we have x squared. Negative 2 times negative 2 is 4. So times y to the 4th. And 4 times negative 2 is negative 8. So z negative 8. Okay. Now from there, we can combine like terms again here. But now we're working on division. So x cubed divided by x squared. Same base, subtract the exponents. 3 minus 2 is just 1. Remember, we keep everything in the numerator, and then we'll worry about it later. Y to the negative 5, y to the 4th, subtract them. You get negative 5 minus 4, so y to the negative 9. Z to the 9th, negative 8. You get 9 minus a negative 8. Be careful with those signs there. That becomes, what, 17? And then we're with the 2 squared. We don't have any other 2's, so I can multiply that on and get 4. Okay? So I combine my x's to get this. I don't know why there's a negative there. 3 minus 2 is just 1. Good catch, Mr. Pons. Combine my y's to give me that. Combine my z's to give me this. And then 2 squared is just 4. And the final thing we do, we want to get rid of negative exponents. Well, the only one I have is y to the negative 9. So I'm going to bring this to the denominator. So my final answer, I have x to the 1st, z to the 17th, times 4. Remember, all these are being multiplied. And this is all over y to the 9. This is fine for now. If you want to make it look really nice, we'll just kind of rearrange the terms. So you get 4x z to the 17th all over y to the 9. And there you go. So I think the key to these, the key to these, knowing your properties, taking it one step at a time. So here we use the product property to get us up here. Here we use the product and power property here to get us to this point. And then we are able to easily use our quotient property to get us here. And then we get rid of the negative exponents and gets us to our final answer. Okay? So just take it one step at a time. Hopefully this makes a little bit more sense to you. And hopefully you like anything raised to the 0 power, because that's nice.